What would happen if you locked a couple of physicists in a room with just a rope, a box, and a black hole? Believe it or not, they might come up with a way to power Earth for centuries. Sounds like science fiction, right? But let's explore what it would actually take to harness the immense energy of a black hole. Black holes aren't exactly part of our everyday experience. To create one, you'd need to compress a star at least 10 times larger than our sun into a sphere, only as wide as New York City. The result is an incredibly dense object with massive gravitational pull. According to Einstein's famous equation, anything with mass holds energy, and black holes have a staggering amount. In theory, we could tap into this energy using technology that isn't too far beyond what we already have. If successful, we'd gain access to more power than we'd ever need. But as always, the reality is more complicated. So, why are black holes considered such appealing energy sources? It all comes down to their efficiency. Let's crunch some numbers. A 3-kilogram kitten contains enough mass energy, if fully converted, to power 6.4 million American homes for a year. Of course, we can't actually extract all that energy from a cat. Today's best energy methods, nuclear fission and fusion, only convert 0.08% and 0.7% of mass into energy, respectively. Black holes, however, could potentially convert around 40% of mass into usable energy. That's a massive leap in efficiency. Still, there's a catch: finding and reaching a black hole. With our current technology, just getting near one would take about 12 million years. So let's imagine we somehow discover a black hole relatively close to Earth. How could we begin to extract its energy? One method might involve dropping matter into the black hole. As objects spiral inward, the black hole's gravity would accelerate them, releasing energy in the process. Alternatively, we could aim for the accretion disk, the swirling cloud of matter orbiting just outside the event horizon. Here, radiation is constantly being emitted, and this is where the Penrose process comes into play. This theoretical idea involves sending a box on a rope near the event horizon to collect radiation. The trick is pulling the box back without it, or the rope being swallowed. Calculations suggest such a box would need to be microscopic, perhaps the size of a bacterium, to be safely retrieved. The concept may sound like science fiction, but theoretically, we could feed these strings of material into a black hole, siphoning off energy over time. It would be a slow process, but if we succeeded, the possibilities would be staggering. With limitless energy, we could shut down polluting power plants and fuel deep space exploration. Humanity could begin building massive structures in orbit and beyond. Our energy problems would vanish, but only if we first solve the colossal challenge of getting to a black hole, unless, of course, we find a way to develop warp drive technology to make the journey a whole lot faster.